Problem 123, Quantum Mechanics. The question is the product delta x delta p of uncertainties in the position and momentum of a simple harmonic oscillator of mass m and angular frequency omega in the ground state ket 0 is h bar by 2. The value of the product delta x delta p in the state e raised to minus ipl by h bar ket 0, where L is a constant and p is the momentum operator is. The given state is ket psi is equal to e raised to minus ipx L by h bar ket 0. Therefore, we can write bra psi is equal to e raised to bra psi is equal to bra 0 e raised to ipx L by h bar. The expectation value of x in this particular state is psi x psi, that is equal to 0 e raised to ipx L by h bar x e raised to minus ipx L by h bar 0. Now we can write it as 0 e raised to lambda px x cap e raised to minus lambda px 0, where lambda is equal to il by h cross. Now let us evaluate e raised to lambda px x cap e raised to minus lambda px. For that, use the standard relation e raised to minus lambda a b e raised to minus lambda a. Let us evaluate e raised to lambda px x cap e raised to minus lambda px. Then resubstitute, we will get the expectation value of x. E raised to lambda px x cap e raised to minus lambda px can be written as x plus lambda times the commutator of px and x plus lambda square by 2 the commutator of px and the commutator of px and x plus lambda cube by 3 factorial the commutator of px and the commutator of px and the commutator of px and x. Now we have the commutator of px and x is equal to minus ih bar. Hence the answer is x minus lambda ih bar plus lambda square by 2 factorial the commutator of px and minus ih bar plus lambda cube by 3 factorial the commutator of px and the commutator of px and minus ih bar. The commutator of px and minus ih bar is 0. Therefore, the second and third term vanish. Therefore, the answer is x minus lambda ih bar. Now, what is lambda? Lambda is il by h bar. Therefore, our answer is x minus il by h bar into ih bar, that is equal to x plus L. Once we have evaluated e raised to lambda px x cap e raised to minus lambda px, then substitute and the expectation value of x is 0, x plus L 0, that is 0x 0 plus 0L 0, and that is equal to, we have 0x 0 is equal to 0, then it is L, the inner product of 0 with itself, that is L, that is the expectation value of x is L. This is our first result. Now let us find out the expectation value of x square. This is psi x square psi, that is equal to 0 e raised to ipx L by h bar x square e raised to minus ipx L by h bar 0, and we can write it as 0 e raised to lambda px x square e raised to minus lambda px 0. Now let us evaluate e raised to lambda px x square e raised to minus lambda px 0. That is equal to x square plus lambda px x square plus lambda square by 2 factorial, the commutator of px and x square plus lambda cube by 3 factorial, the commutator of px and x square. And this is equal to x square plus lambda 2x minus ih bar plus lambda square by 2 factorial px minus 2x ih bar plus lambda cube by 3 factorial px, the commutator of px and minus 2i h bar x. Here we have used the relation. The commutator of px and x raised to n is minus nx raised to n minus 1 ih bar. Therefore, our answer is x cap square minus 2i h bar x lambda plus lambda square by 2 factorial minus 2i h bar, then the commutator of px and x plus lambda cube by 3 factorial minus 2i h bar, then the commutator of px and x. The commutator of px and x is minus ih bar. Now we can see that the commutator of px and minus ih bar is 0 and the commutator of px and x is minus ih bar. Therefore, our answer is x cap square minus 2i h bar x. Then what is lambda? Il by h bar minus lambda square ih bar minus ih bar plus 0. Now let us substitute the value of lambda square. Thus we can say e raised to lambda px x square e raised to minus lambda px, and that is equal to x square plus 2lx plus, here you have to substitute the value of lambda. So our answer is x square plus 2lx plus, it is not plus, it is minus h bar square into minus l square by h square, that is equal to x square plus 2xl plus l square. Therefore, e raised to lambda px x square e raised to minus lambda px is expectation value of x square is 0 e raised to ipxl by h bar x square e raised to minus ipxl by h bar 0, that is 0 x square plus 2xl plus l square 0, and that is equal to 0 x square 0 plus 2l 0 x 0 expectation value of x square is 0 x square 0 plus 2l 0 x 0 plus l square, the inner product of 0 with itself. Now what is 0 x square 0? It is h bar by 2m omega. Then 0 x 0 is 0. Then l square into the inner product of 0 with 0 is 1. Hence, the expectation value of x square is h bar by 2m omega plus l square. We have already evaluated the value of expectation value of x, that is equal to L. Therefore, we can write delta x, that is equal to root of expectation value of x square minus expectation value of x whole square, and that is equal to root of h cross by 2m omega plus L square minus L square, that is equal to root of h cross by 2m omega. Delta x is root of h cross by 2m omega. So we have evaluated delta x. Now we have to evaluate delta p or delta px. So first of all, we have to find out what is the expectation value of px. That is to find the expectation value of px. Expectation value of px is 0, e raised to ipx L by h bar, then px e raised to minus ipx L by h bar 0. We have e raised to lambda a, e raised to minus lambda a is the a operator a itself. Therefore, we can say the expectation value of px is 0, px 0. What is 0 px 0? It is 0. For harmonic oscillator ground state, the expectation value of momentum is 0. Therefore, we can say the expectation value of px is equal to 0. Now let us find out the expectation value of px square, that is equal to 0, e raised to ipx L by h bar, px square e raised to minus ipx L by h bar 0, that is 0, e raised to lambda px, px square e raised to minus lambda px 0. Now let us evaluate e raised to lambda px, px square e raised to minus lambda px, so that we will get the expectation value of px square. To evaluate e raised to lambda px, px square e raised to minus lambda px. E raised to lambda px, px square e raised to minus lambda px, that is equal to px square, then px square plus lambda, the commutator of px and px square, plus lambda square by 2 factorial, the commutator of px and px square, plus etc. And we can see that the second term and third term and higher term will goes to 0. Therefore, our answer is px square. Now let us find out the value of the expectation value of px square. That is, expectation value of px square is 0. Now it is px square 0. Now what is 0 px square 0? That is m omega h bar by 2. Thus we have evaluated px square and px. Therefore we can find out delta px, that is equal to root of px square minus px square. We have already evaluated that the expectation value of px is 0. Therefore, delta px is m omega h bar by 2 minus 0, that is equal to root of m omega h bar by 2. Now let us take the product of delta x and delta px. We have already determined the value of delta x as root of h cross by 2 m omega. Therefore, what is delta px and delta x? That is, it is equal to root of m omega h bar by 2. Delta x delta px is equal to root of m omega h bar by 2 into h cross by 2 m omega. That is, delta x delta px is root of h cross by 2 m omega into root of m omega h bar by 2. That is, delta x delta px is h bar by 2. Therefore, option C is the correct option.